Computer-aided disassembly planning of 3D objects has various applications in computer graphics. For instance, partial disassembly procedures can be used to identify efficient ways to extract specific parts that may need replacement or maintenance. The corresponding instructions can be animated for clarity. If we invert a computed disassembly sequence, we can obtain illustrative assembly manuals. Disassembly sequences can also be used to create 3D explosion diagrams and X-ray visualizations. However, previous approaches of automatic disassembly cannot be applied to complex objects. A prominent issue with most existing methods is their limitation to small assemblies. Our system is capable of handling assemblies that contain several hundreds or even thousands of parts. While previous disassembly planners commonly restrict themselves to straight-line translations, we also evaluate multi-directional motions for adding or removing parts to an assembly. Even for simple assemblies, there may be several ways to achieve the same goal. In this example, the RAM from a press can be disassembled in at least 2 different ways. In order to allow the user to adapt sequences that are found by our system, we provide several methods for editing part constraints. The most intuitive method is designating a direction in which specific parts should be removed, as shown here. A single constraint suffices to switch between the 2 proposed disassembly sequences for the RAM. As part of disassembly sequence editing, we support interactive partitioning to create subassemblies that restructure the hierarchy of an assembly. During sequencing, each subassembly is treated as an individual entity until it has been separated from the remaining structure. Therefore, the way in which an object is partitioned can influence the disassembly sequence. For example, instead of disassembling the leaning tower piece by piece, we allow the user to select parts representing separated layers of a stacked assembly and partition it accordingly. Partitioning can also be used to resolve interlocked groups of parts. Here, we combine a group of 4 parts into one subassembly to enable their removal as one. Highly complex assemblies, such as the leaning tower, are often composed of only a few basic repetitive constellations. To avoid excessive interaction with the data, the user can let the system search for recurring partitions and automatically merge them. Due to the vast amount of parts and interactions involved, traditional visualization systems fail to produce comprehensible graphics for extensive disassembly sequences. In order to review long sequences, we allow for dynamically switching between overview and detail visualizations, and allow for presenting sequences as either assembly or disassembly procedures. Here we show the use of our techniques to plan the assembly of the Eiffel Tower model. We provide fast-forward animations to allow the user to explore the whole sequence. The fast-forward animation can be paused at any time. We can at all times show additional detail by displaying relevant action diagrams or detailed animations. The thumbnails at the bottom of the screen can be used to skip back and forth between different stages of the procedure and allow for efficient navigation. For many applications, we do not need to present the complete disassembly sequence of an object. In this example, we only consider a sequence for removing a ball bearing from an engine. For short sequences with a limited number of removal directions, a sufficient overview of the entire procedure can be given by presenting a 3D exploded view. Depending on the complexity of the sequence, we allow substituting the fast-forward animations with 3D exploded views as a previewing technique. Interactions between all overview and detail visualizations remain integrated. Clicking an exploded part locates the corresponding action diagram and initiates the first progressive animation.